Hello and welcome back to the news channel. My name is Eddie Dwan, and today I'm interviewing a senior design team tasked with making a wake-up harvester. So starting off, I would like to ask, what is this project about?
Currently, batteryless and wireless IoT devices are only able to reliably communicate with servers which are always on and always accepting wireless network connections. This has worked so far, but as the Internet of Things continues to grow, it is anticipated that this will no longer be sufficient. Instead, it will become necessary for devices to not only communicate with servers, but also with each other. This presents a challenge for IoT devices which are batteryless and frequently put themselves into low power modes to conserve power, since two devices can only communicate with each other when both devices are in an active state. However, these devices typically spend most of their time in a low power state, making reliable communication next to impossible. Our project focuses on the design of an IoT network which is composed of a collection of batteryless and wireless nodes. However, what is special about our wireless nodes is that they are able to be woken up by a wireless RF signal even when they're in a low power state. This means that our nodes can signal neighboring nodes to activate and exit their low power state, even if they are standing by, allowing for reliable node-to-node communication and the transferring of information from one node to another.
So I guess the next question would be, what is the purpose of this project?
This project is not intended to satisfy commercial products, at least not yet. Instead, it is intended to be used by researchers at Iowa State University who are researching low-power wireless IoT devices and methods of communication for these devices.
Nice. So what would you say are the different components that make up this project?
In order to implement this project, we're going to make use of some third-party components since they're going to offer a more reliable and power-efficient solution. Beyond that, some components are beyond our knowledge to create. To start, we're going to be using a PowerCast P2110B. This component is a harvesting unit, which includes an RF to DC converter and a boost converter, along with a voltage monitor. With this system, we're going to be able to harvest ambient signals and charge a capacitor, which in turn will power the onboard boost converter, providing the system with 3.3 volts of power. The main part of the project is the TI-CC1352 microcontroller. The user will be able to use this in any way they see fit. It will be directly powered from the harvester. In order to provide the triggering capabilities, we're also going to be using an ON semiconductor transceiver called the AX5043. While we could use the harvester to power this device, it will be more efficient to find a boost converter that is better equipped for small loads to power it, which led us to choose the TI-TPS61100, which is a DC to DC converter. This is going to be directly connected to the charge capacitor and will only power the transceiver. In addition to these components, we're going to be using 3 different antennas that the manufacturers recommend, as well as a variety of small analog components like capacitors and resistors to match the manufacturer's instructions for use.
What are you using to design this circuit? How does that work?
To design the project, our team is making use of several industry-level tools. For example, we are using Altium Designer for schematic and PCB design and Keysight ADS for RF simulations. Using these industry tools will improve the reliability of our design and design files, as well as ensure that the project can be easily picked up in the future by our customer if necessary. For both software and hardware version control, our team is using Git, ensuring that our revisions are organized and well documented. Project management is being conducted through Trello, which allows us to efficiently designate tasks to team members and to track progress.
What are the technical challenges in achieving this vision?
So as we covered, our RF harvester does not have consistent harvesting rates. We have been given a couple maxes, but we should not expect max power constantly from this. It all depends on the area we're in, how far away the source is, and so on. Many traditional low power components are simply not low enough power for us. A low power component can cover 1/4 of our actual max power usage. This is not usable. Many components offer sleep options, but for example, our receiver, what good is a sleep option? It needs to be on constantly in order to receive the wake up signal itself. It cannot be woken up by another signal. We're doubling down on some components. We need to maximize our efficiency, as we stated, such as the MCU transmitter is simply not power efficient comparatively to another chip transceiver. Also, we're looking at other options for DC to DC converters that are much more power efficient at the lower levels we're looking at.
Who might benefit from this project? Do you have any clients in mind?
So long term, there are a lot of different people that could benefit from this type of project. What we're trying to solve in this project is creating a device that will allow us to wake up the IoT device when there's enough power present, and that could be used in a variety of different applications, such as an office building. Something that is a little bit more short term is there are a lot of people doing research on batteryless IoT device networks, and by creating this wake up radio system, they can experiment with how this may improve or be implemented into a IoT device network.